Hello my dear students. Today we will be doing Physics of class 10th. Chapter Electricity. It is chapter 12 of your NCERT science book. We will begin with the topic Electric Circuit. The spelling is C-I-R-C-U-I-T, but it is pronounced as circuit. Now, what is an electric circuit? A continuous and closed path of an electric current is called an electric circuit. I repeat, a continuous closed path of an electric current is called an electric circuit. Simply, a continuous path through which electric current can flow. We know that electric current can flow through a wire continuously. So this wire is an electric circuit. Not only wire, along with that, some more devices are needed, then only electric current will flow through it. That we will come to the next part of the chapter. So a continuous closed path through which electric current can flow is called an electric circuit. Now, the other components that are used in an electric circuit. See, this is a circuit diagram. Means it is a diagrammatic representation of a circuit in which electric current is flowing continuously. This is the symbol used for a cell. All of you are familiar with a cell, a simple cell. And all of you know there is a flat surface for a cell, which is the negative terminal of the cell. And there is a metal cap at other end, which is known as positive terminal. So every cell has two terminal, negative terminal and positive terminal. Now this cell is represented diagrammatically like this. A longer line that represents positive terminal and a shorter line which represents negative terminal. And this is the symbol used for electric bulb. This is the symbol used for a plug key or switch. And you must see, if there is a point at the middle, it means closed key. Closed key means the switch is on. Then only electric current will be flowing in the circuit. Now, let us discuss the direction of electric current. We know that electric current is nothing but the flow of electric charge, that is electrons. Electric current is the flow of electrons. In class 9 you have studied electrons are negatively charged. So this is the negative terminal, this is the positive terminal. So when we are connecting the negative terminal and the positive terminal with the help of a wire, the electric current is now flowing through this wire because electrons are flowing from one end to other end. Now, even though electric current is the flow of electron, the earliest scientists believed that electricity is actually flowing from positive to negative. See, even today, we take the conventional direction of electric current as plus to minus. So in an electric circuit, we will show you. This is the positive terminal and this is the negative terminal. So arrow mark will be shown in the circuit showing the path of electric current. So conventional direction of electric current is from plus to minus. But actually the electrons are flowing from minus to plus. So we may also say like this, direction of electric current is the direction opposite to the flow of electron. Electrons flow from minus to plus, but direction of electric current is taken as plus to minus. Now, the other symbols that are commonly used in electric circuit. As I told you, this represents a simple cell. Now, when more than one cell, two or more cells are connected together, it is called a battery. A single one, this is called a cell because it has only one negative terminal, one positive terminal. When we connect one more cell along with it, like in our remote, we are using two, and in many devices we are using many. So when more than one cell is connected to one another, it is called a battery. Its symbol is like this. One longer line and smaller line represent one cell. When one more longer line and smaller line are added, it is a combination of two cells. Combination of more than one cell is called battery. So remember the difference between cell and a battery. Now the other commonly used symbols are, as I told you, this represents open key or the switch is off. This represents closed key, or now the circuit is closed, electricity will be flowing. Another symbols that are commonly used, this is used for bulb. Bulb. Now the other symbols are a circle and a capital A inside represent ammeter. Circle with capital V inside is used for voltmeter. We will come across ammeter and voltmeter in the later part of this chapter. Ammeter is used for what? Voltmeter is used for what? This is only the symbols. Ammeter is used for measuring electric current of a circuit. Voltmeter is used for measuring the potential difference of a circuit. Another common symbol is this, and this represents a resistor. This is the symbol for resistor. Now what is a resistor? In our common language, all the electrical appliances are commonly known as resistors. Bulb is a resistor, fan is a resistor, and electric iron is a resistance. So this is the symbol for resistor, voltmeter, ammeter, cell, battery, open key, closed key, and bulb. Our next topic is electric current. Electric current is represented by capital I. The definition of electric current is the rate of flow of electrons or the rate of flow of electric charge in a circuit is called electric current. Now what is meant by rate? Rate means per time. How many electrons or how much electric charge is flowing through a circuit in 1 second time is called electric current. So electric current can be defined as quantity of electric charge flown per time. Here Q stands for quantity of charge flown. Small letter t for time. So the formula for electric current I is I is equal to Q upon T. Q for quantity of charge, T for time. Now we know that the SI unit of quantity of electric charge is coulomb, and the SI unit of time is second. So electric current I is quantity of electric charge transferred upon time taken, time for which it was transferred. Now coming to its SI unit, it is coulomb upon second. But 1 coulomb per 1 second is given a special name and that is called ampere, which is represented by capital A. This ampere is named after the French scientist André-Marie Ampere. The French scientist André-Marie Ampere worked on this principle. So ampere word is taken from this French scientist. So once again we can define 1 ampere. Now what is 1 ampere? When Q and T are given the values 1 and 1, then I will also become 1. This is the way to define 1 ampere or anything in 1 in physics. In that formula, make all the things 1 1. Now how can we define when Q is equal to 1 and T is equal to 1? What can be the statement? When 1 coulomb of charge is flowing in a circuit for 1 second time, the electric current in that circuit is said to be 1 ampere. I repeat, when 1 coulomb of charge is flowing in a circuit for 1 second time, the electric current in that circuit is said to be 1 ampere. Now, the other units of ampere, the smaller units of ampere are milliampere and microampere. 1 milliampere, small m, capital A. 1 milliampere is equal to 10 raised to minus 3 ampere. Milliliter, milliliter means 1 upon 1000. So here also 1 milliampere is equal to 1 upon 1000 ampere or 10 raised to minus 3 ampere. Another smaller unit is called microampere. This is the symbol for microampere. 1 microampere is equal to 10 raised to minus 6 ampere. Both these conversions were asked in 2020 board exam. So remember, this is a 2020 board exam question. 1 milliampere is equal to 10 raised to minus 3 ampere. 1 microampere is equal to 10 raised to minus 6 ampere. So I told you, electric current is nothing but the amount of or coulomb of charge flowing in 1 second in a circuit. Now, we know that electric current is constituted by the flow of electrons. Now, what is the charge of 1 electron? 1 electron has a charge of 1.6 into 10 raised to minus 19 coulomb. So, let us calculate how many electrons are needed for making 1 coulomb. So, 1 coulomb is equal to 1 upon 1.6 into 10 raised to minus 19. This will come about 6 into 10 raised to 18. So remember, 1 coulomb consists of 6 into 10 raised to 18 electrons. I think this part is clear to all of you. So electric current is defined as the rate of flow of electric charge. I is equal to Q upon T. SI unit is ampere. Smaller units are milliampere and microampere. The charge of 1 electron is 1.6 into 10 raised to minus 19 coulomb. So 1 coulomb consists of 6 into 10 raised to 8 electrons. Now I am moving to the next topic. Our next topic is electric potential and potential difference. Electric potential and potential difference. As we know, water always flows in a pipe from a high pressure region to low pressure region. Similarly, electricity will also flow always from a high potential point to a low potential point. So, the other word we can use for this pressure is potential. In terms of electricity, we use the term potential. So, in a circuit, every point of a circuit will have a particular potential. Now what do you mean by the potential? The correct definition in physics for potential is, say for example, A is a point of the circuit. Electric potential of point A can be defined as the amount of work done for bringing 1 unit charge or 1 coulomb charge from infinity to this point is called electric potential of point A. I repeat, the amount of work done to bring 1 coulomb charge from infinity to point A is called electric potential of point A. Now, we say potential difference. Potential difference means, say I have taken 2 points. This is point A and this is point B. Potential difference between these 2 points is defined as the amount of work done for shifting 1 unit charge or 1 coulomb charge from point A to point B is known as potential difference across A and B. I repeat, the amount of work done for shifting 1 unit charge or 1 coulomb charge from point A to point B is called potential difference across A and B. The potential difference is represented by capital V. Capital V is the symbol for potential difference. So potential difference V is equal to amount of work done, the total amount of work done upon quantity of charge transferred. If W joule of work is done for shifting Q coulomb of charge from point A to point B, then the potential difference across point A and point B is calculated as V is equal to W upon Q. W is the work done, Q is the quantity of charge transferred. We know that work done is measured in joules. SI unit of work done is joule. So remember the very important formula, V is equal to W upon Q. Coming to the unit, work done is measured in joules, quantity of charge is measured in coulomb. So it is joules per coulomb. But 1 joule per 1 coulomb is given the special name called volt. V-O-L-T, volt, and it is represented by capital V. This volt is named after the Italian physicist Alessandro Volta. This name is taken after the Italian physicist named Alessandro Volta. Now let us define 1 volt. When do we say the potential difference across 2 points is 1 volt? Once again, make W is equal to 1 and Q is equal to 1. Then V will also become 1 and define it. So how can we define? When 1 joule of work is done for shifting 1 coulomb of charge from one point to another point, the potential difference across these 2 points is said to be 1 volt. I repeat, when 1 joule of work is done for shifting 1 coulomb charge from point A to point B, then the potential difference across these 2 points A and B is said to be 1 volt. I hope it is clear to all of you. So that's all for today. So the important points that we have discussed today: what is electric current, what is electric circuit, a circuit diagram, the symbols used in a circuit diagram. Then we have studied electric current, I is equal to Q upon T, its SI unit is ampere, symbol capital A. The device used to measure electric current is ammeter. Then potential and potential difference. Potential is the amount of work done for bringing 1 unit charge from infinity to that point. Potential difference is the work done for shifting 1 unit charge from one point to another point. So V is equal to W upon Q. SI unit is volt. Thank you.